Hey guys, hope you're having a good day. So today we got an air compressor, a little bit different than a mower or weed whacker. It's a Craftsman 1 horsepower 7-gallon. Pulled this one from the curb on trash day. Let's take a look at the label here, maybe tell us how old it is. Maybe 2005. So I figured, hey, let's see if we can't fix it, or worst case, we'll figure out why they tossed it. Let's pull it inside. All right, I drug this thing into my basement, and we're going to see what we got all coiled up here before moving forward. I'm going to bring you into this side, and I think there's some things we got to check on the other side too. So looks like we've got maybe a 1/4 inch coil, a line with no fittings on it. And then we'll take a look at this power cord. Maybe there's a power cord issue. No, I don't see anything. All 3 prongs are there. No insulation damage. So let me bring you in here. So this is our control side. We got our 2 gauges here for tank pressure and then line pressure out to whatever tool you're using. Looks like on-off switch, look like an auto and an off. Pressure relief valve, that's moving fine. That'll make sure you don't have too much pressure in your tank. And then your regulator knob to adjust the pressure through the hose that you're using. And then obviously we've got a female connector here. So I don't really see anything wrong on this side. On the other side, we've got the intake filter and the oil check sight glass. So we'll check that next. Okay, we're on the engine side of things here, and this is our air filter and then our sight glass for our oil. There's a little red dot in here, and you got to make sure on a level surface that your oil is across that dot. And I can see right now that it's maybe overfilled, but that should be okay. And then we'll check the air filter here, make sure there's not a blockage. And that looks okay. So nothing really obvious on this one that's wrong. So let's plug it in and see what they were dealing with before they kicked it to the curb. Okay, well I think I got you set up so you can see the pressure build or not build, depending on what it's doing, but we'll get this thing plugged in and let it run for a little bit. And this was on. All right, well, I think we found our problem. I was running this somewhere between 5 and 10 minutes, just seeing what the pressure would do, and it never really came off of 25, looks like somewhere between 20 and 25 PSI. So I think we have a problem with it making pressure to the tank. So my guess is we probably have to get into this engine, but let me back you up and show you kind of what I was looking for as this thing was running. So while I had you guys pointing at those gauges to see that progression, I was slowly moving my hand around the machine to kind of feel for some leaks or obvious leaks that would cause the issue of not building pressure once I noticed it wasn't building pressure. And I did find there was a kind of a pulse over here that slowly went away as pressure built. So my guess is it's maybe some kind of cold start feature so that it's a little bit easier for the engine to start if there's not pressure in the line already. But I did feel kind of like some air pressure over here. And I did notice that this black plastic piece is the intake to cool the engine. So it will pull air through here and across the engine. But I noticed that there was a pulsating air movement over here, mainly around this filler cap for the oil that has a vent, and the intake, which has 2 holes on the side so that air can get sucked into the engine. So while it was running, I was feeling some pulses out of the engine, which is not what this is supposed to be doing. Those are supposed to be intakes, and the oil's supposed to be sealed off. So my guess is we have some kind of a head problem. Maybe there's like some check valves in here that have gone bad, but we'll have to take this cover off first to get access to that. And I'm going to have to let this thing cool down first because it was running for about 10 minutes. So I'll bring you back and we'll start taking this thing apart. Okay, so it looks like 3 screws on this side and then a mirrored set on the other side. So 6 total. Take this black piece off. Okay. Okay, let me move this to get maybe a better view for you. Okay, so while this thing is still cooling down, I was kind of looking at it and poking around to see how it's constructed to maybe better understand why this is failing. And the best way I can describe how this works, for those of you who may not know, is you plug in the cord that drives this electric motor, which in turn drives the crankshaft on this normal combustion type engine. And that creates the compression up here, and it would go through maybe a valve block here to get pressure into the tank. So if you can think of this section as kind of a lawnmower engine, and instead of gas going into the cylinder and getting exhausted out to transfer power to a blade, this is essentially working in the opposite direction, where the power is coming in the other side of the engine and your output is here, which is just compressed air to the tank. So that's the best analogy I can put together to help maybe understand this if you're not familiar with air compressors. But I think we have a problem in the head here. I don't know if it's maybe a gasket problem or there's a problem with the valve block here. There's kind of a crack in the gasket here, which makes me believe it's a gasket. But we'll have to take this off and probably this fitting too to lift that off to see what's underneath there. And I'll get you pulled in. We'll start doing that. Okay, I'm just pulling the relief valve here, make sure there's no compressed air in here. I don't want to blow this thing through my ceiling. Pull this off first. Wrong way. There we go. So we're loose there. And then we've got a couple Allen head screws here. That was pretty loose. Okay, should be loose enough. Let's see what we got. Okay. Trying to get these screws out of here so I can take this intermediate plate off. So there's a thin piece here. It's going to come off. I need a screwdriver. Okay, so first off, I wonder if it's this, or if I did that, taking it apart. So maybe this gasket blew out and it's mixing the intake with the exhaust to the tank here. That would make sense because we're getting air out the intake. So maybe this is our issue. Our gasket under here. Lose that. That went up in here. So that gasket looks okay. I'm not going to mess with that. I'll have to look to see if it was this way or this way. I think it was this way. Yeah, to match up with that. Okay, so let me look this up. I don't know if this gasket's available. If it's not, we might be able to make one. But let me look that up and we'll bring you back. Okay, so I was able to look some stuff up online. We'll get to that in a second. But I first wanted to show you guys how this valve block works. So we've got two identical plates, top and bottom. On one side of the plate, we've got two holes with a recessed area and then a single hole. And then sandwiched in between, we've got these flexible pieces of metal that are acting like reeds. So if you can imagine the piston moving up and down, we'll talk about the intake side first. When the piston's moving down, it's creating vacuum and will pull this piece of metal down, allowing air through the intake into the cylinder. And then on its way back up, it will push that piece of metal against this top plate sealing it off. In that same set of motions, the exhaust side, when the cylinder is moving down, is sealing against the bottom plate. And then on its way back up, it moves this piece of metal to allow air into the tank. So if we lay our gasket on top of here, we can kind of see how the failure was causing our compression problems. These two chambers are supposed to be kept separate with the shape of the head here. So if we have a failure in the gasket between the two chambers, it's allowing air to exchange between them instead of going in the intake, through the cylinder, and then out into the tank, kept completely separate. And with them being exchanged, that's what was getting our pulses out of the intake side, because the compression side was actually moving through here and then out the intake. So I thought that was interesting to share, and we'll keep moving here in a second. So our plan to replace that gasket. I did look online and found a pump gasket kit, E100959. It comes with all the gaskets for the entire cylinder all the way down to the base. There's like 4 or 5 gaskets, and I really only found it on Amazon or eBay, so I don't know if they're knockoffs or original or what, but in finding that, I did find the manufacturer date. It was 09-2007. It was an inch lower, written right on the label, than I was looking at the serial number. I was too busy trying to decode that than looking at the entire label. So we got a 2007 compressor, and instead of buying that kit, which was I think about $15-20 range, I'm going to try to make my own, since this is the only one that's bad. And I'm going to use this Felpro material, 3157, and it says it's good for oil, water, gas. So I think that's a good material for this, since I think oil does get into the cylinder. As you can see, there's kind of discoloration here. So I'm going to get this cut out using this as a template, and we'll start getting this thing back together. Okay, I think we're good. Turned out okay. Let's move back to the compressor. Okay, so we're going to have to be a little delicate here. Make sure our exhaust side reed is free and in the slot. And drop that on. And then our head. So our intake went that way. And you want to make sure your holes line up, and it looks like we're off. It needs to be rotated like that. Yeah, just like that. Make sure that exhaust reed's still free. Okay. So and I've got no idea what the torque specs are on this, so I'm just going to tighten it down until I think there's a decent crush on the gasket all the way around. I think that's good for that. It wasn't very tight to begin with. Okay. Let's get that plastic back on. I'll bring you around here to the gauges. We'll plug this thing in. Okay, so we got the shroud back on. Remember, that's important because that's the cooling for the electric motor and the cylinder. So we don't want to be testing very long without that. So I just threw it back on since it's only 6 screws. And I think we're looking for somewhere between 100 and 120 here. So we'll get this plugged in and let it run. All right, awesome. 120. I don't hear any leaks anywhere. I think we're all good. All right, just a quick test with an air gun here. Awesome. Okay, well, I think we're all done with this one. Our tank pressure is stopping somewhere between 110, 120, just like it's supposed to. And our regulator works, and it's outputting air just like we tested with that air gun. So I'm not sure if I mentioned it, but that whole roll of gasket paper only costs about $10. So I don't know if we even have $1 into the material alone on that gasket, you know, and then plus the time to diagnose it and then actually make that gasket. So not too bad. And one thing I want to touch base on is the oil level. After I got done running this thing, I checked it again, and it's right across where it's supposed to be, right across that red dot. So we're all good there. Didn't need to touch that. So hopefully this helps somebody out, or you guys found this entertaining. Thanks for joining me on this one, and I'll catch you on the next one.